We're going to piggyback a little on yesterday's lesson of financial models and move into growth and decay. And again, this is exponential growth and decay, not linear. Growth and decay equation is A of t is equal to a sub o e to the kt. We know this is a growth if the k value is greater than 0 and a decay if the k value is less than 0. Each of these terms correspond to the following amounts. A of t is like your y, your final amount. A sub o is your initial amount. K is a growth or decay constant, so this is going to be the same for any type of growth or decay of the problem's specific nature, and t is the time. So in this first problem, we have an example saying the population of the U.S. was 203.3 million in 1970 and 300.9 million in 2007. And if we know this growth was exponential, or given that the growth was exponential, we want to write an equation that models the growth. So to write an equation of A of t equals a sub o e to the kt, basically what we need is we need a value for the initial amount and the k value. We have the initial amount, so that's great, but we need to find a k value. So let's go ahead and do that. We know that our final amount is 300.9, and this is all in millions, so we'll just leave 300.9. Initial amount 203.3 e to the k. Now this happened over this many years, from 1970 to 2007. So that was over 37 years. If we solve for k in this case, then we'll be able to write our equation. So let's go ahead and do that. Divide by 203.3 first. So I have 300.9 over 203.3 is equal to e to the 37k. I want to bring the 37k out in front, so I'll use a natural log. The natural log of quantity 300.9 over 203.3 will equal 37k times the natural log of e, which we know is 1. Therefore, the natural log of 300.9 over 203.3 over 37 is equal to k. So if we can pop that in our calculator and get a value. So in this case, k is equivalent to 0.010597. It's going to be fairly important that we carry these decimals out averagely far, because we'll be dealing with big numbers typically. And now if we write our equation is a sub t equals 203.3 e to the 0.010597 t. And that's our growth equation that models the situation that we have. Our next problem is a little more intricate in that it tells us the half-life of a carbon-14 element is 5,715 years. We want to know how old is a sample of material that contains 76% of its original carbon-14. And we have to assume exponential decay. Now, this concept of half-life talks about how long it takes for half of the material to decompose. So it tells us that we have an exponential decay of half of the material taking this amount of time. They don't give us a k value, but they do tell us how long that takes. We can find out a k value just like we did in the previous problem. So if we don't know how much we originally started with, this is again like the problem we did the other day of doubling our money, but now we're going to half our value. We can start with an initial amount and finish with half that initial amount, and that's e to the k times 5,715 years. From this we can find our k value, divide both sides by a sub o and get 0.5, because that's a half, equaling e to the 5,715k. Natural log both sides is equal to 5,715k ln e, which we know is 1, so the natural log 0.5 over 5,715 gets us our k value. And k in this case equals negative 0.000121285. So what we have now is we have y equals, or we could say a equals, I don't care, a sub o e to the negative 0.000121285 t. Now in our problem, they tell us that we have this sample that contains 76% of its original amount. So if it contains 76%, then 0.76 a sub o is equal to a sub o e to the negative 0.000121285 t. And again, we're solving for t. So I divide both sides by a sub o, we get 0.76 equals e to the negative 0.000121285 t. Natural log both sides. Bringing that term out in front. Divide. Natural log of e we know is 1, so therefore t equals the natural log of 0.78 over negative 0.000121285, and that's going to equal t. And in this case, t will be equal to roughly 2,371.95 years. So it's really a two-part problem. First part finding k, second part using the information given to find out the new value of t. And those are really the two types of problems you're going to have to deal with. So make sure you go fill out a summary form, fill out my math lab, and we'll talk more about this tomorrow.